Chapter 2. Spatial Coding as Integrative Processing of Inputs from Vision, Touch, and Movement. The Reference Hypothesis. This chapter examines how spatial information is integrated across sensory modalities, vision, touch, and movement, to create a coherent perception of space. The chapter introduces and elaborates on the reference hypothesis, which suggests that spatial coding relies on combining inputs from multiple sources to form a consistent spatial framework. Vision is often viewed as the dominant modality for spatial perception, but touch and movement also contribute significantly. Spatial tasks often depend on the integration of sensory inputs to establish location, distance, and direction. Studies show that the brain processes spatial information by combining inputs from different modalities. For example, blind individuals use touch and movement to compensate for the lack of visual input. Sighted individuals also rely on body-centered or proprioceptive cues in conditions where vision is limited. Cross-modal studies demonstrate that spatial information from one modality, like vision, can transfer to another, such as touch. Vision provides external reference frames for spatial coding, such as the relative positions of objects in the environment. Blind individuals rely more on body-centered reference frames, using touch and proprioception for spatial tasks. Despite the lack of vision, blind individuals can achieve remarkable spatial accuracy, suggesting that vision is not always necessary for spatial coding. Studies with congenitally blind children reveal that they perform well on spatial tasks when reference cues are available. Errors in spatial tasks often occur when reference cues are disrupted, highlighting the importance of reliable reference systems. Neural plasticity allows the brain to reorganize and enhance the use of non-visual modalities in blind individuals. The visual cortex in blind individuals is often repurposed for processing touch and auditory information. Spatial processing is viewed as an active process of integrating inputs from diverse sources rather than relying solely on one modality. The reference hypothesis emphasizes that spatial coding involves aligning sensory inputs to reference cues such as body-centered cues, for example, the relative positions of body parts, and external reference frames, like the positions of objects in the environment. Spatial coding is defined as the integration of inputs to determine location, where is it, distance, how far is it, and direction, which way to go. This definition focuses on functional rather than sensory aspects of spatial processing. How do different modalities interact to improve spatial accuracy? What factors determine the dominance of one modality over others in spatial tasks? How can reference cues be manipulated to improve spatial performance? Understanding how blind individuals process spatial information can inform the design of tools and technologies to enhance mobility and independence. Training programs can teach individuals to use non-visual reference cues more effectively, especially in environments with limited visual information. The findings provide insights into how neural networks integrate multisensory inputs, contributing to theories of sensory processing and plasticity. Chapter 2 highlights the complexity and adaptability of spatial coding. By integrating vision, touch, and movement, the brain creates flexible and reliable spatial representations. The reference hypothesis underscores the importance of reference cues in spatial tasks and lays the groundwork for exploring how different sensory modalities interact.